welcome to today's problem, maximum depth of a binary tree. So you're given the root of a binary tree, and you want to return its maximum depth, where the maximum depth is the number of nodes along the longest path from the root down to the farthest leaf node, where these are leaf nodes over here. So we're given this example, this tree over here, and we know that the output is 3 because it's 3 down. Well, that's the depth of the number of nodes from the path. So we go down 3, 20, 15, or 3, 20, and 7, and we know that the final output should be 3. For an example, like this one, 1, null, and 2, the depth should be 2 because 1 can like go down to the right and hit 2 for basically that one's depth as well. So there's going to be a couple different ways in doing this. The first one is by using a recursive depth first search, which can be really simply implemented by returning 1 plus the maximum of the left value and the right value. I'll go ahead and quickly write this up just to show you guys. So we want to return 1 plus the maximum of self dot max depth roots dots left, as well as the maximum depth maximum depth of the roots right. And then we'll have the base case, if not roots, return 0. For one of the leaf nodes, check if it's null. Basically it'll return that as the value. So we'll go ahead and run that just to verify that it works. Accepted. Quick submission over here. Okay, that's good. So yeah, that's one way of doing it. Another way that you can also do it is by utilizing a iterative depth first search using a stack instead. So to explain that, basically what we do is we have a stack, right? We have a stack like this, for example. And what we do is we add the initial root node onto the stack with, let's say, like a depth of 0. What we can do now is we can pop this item from the stack. We have the root and we have the current depth that we're on, and we'll append its left and right children to the stack. So in our situation, we have 3. We're going to add its left and right children, 9 and 20, and then we'll also add 1 to the depth. So at this one, this is a depth of 1. This is a depth of 1. Since it's since we're going to be adding that one's left and right children, we can we'll add it to the stack. We'll go ahead and do that for the children as well. This one will be at a depth of 2, and then we'll add that one's children, which are null values, with a depth of 3. So we'll do that. And so since we're doing it this way, what we can do is we can have another value result which keeps track of what the current maximum is, which we can then return at the very end. So yeah, so first things first, we want to go through the element in the stack. So while the stack exists, we want to check to see what the current one, and we want to see what depth it's currently at. So we can do that by popping the latest element from the stack. So stack.pop. From there, what we can do is we want to add its left and its right children. So we'll do stack.appends cur.left, adding the depth, plus 1 because we're going down 1 level. And we'll do the same thing over here. Cur.left 1 plus depth. Well, cur.right actually. So we'll go ahead and append its children, and we want this to only happen basically if the current node isn't empty. So we only want to append its children if it does have children, if it's not just an empty node. So the next thing we're going to want to do is, like I said before, we're going to want to check to see what the maximum is at that given point, at this current element within the stack, or the current node. So we'll check the res to see what the maximum is of itself, as well as the current depth level that it's on. So why not put this inside this current if statements? The reason being is that it can also work for ones that are null. So like, let's say like with this example, we have 3, we add its children to the stack. Like we pop this, add its children, we pop this, add its children. For this one, 15, we pop it, we add its children, which are null values, but the depth of those children, the depth value, is 3. And we want that to also be included as the part of the output, because you want to like calculate the maximum in like that way. another way you could do it is we could start off at a depth of 1 for 3 and then not include those children, but I think this example makes more sense in my head personally. So yeah, basically we'll go ahead and run this now. At the very end, we'll turn the final value, and what it should do is it'll return the maximum depth. Go ahead and submit it. There you go. So those are two different ways of figuring out what the maximum depth of a binary search tree is. Yeah. Oh, also another note to add, for my videos, I'm experimenting with whether or not it's better to write pseudocode, like in sort of like comment form, or whether or not to go about my explanation while coding. It's something I'm still debating back and forth just to see what will convey my answer the clearest. But if you have any suggestions on that, let me know in the comments below. But yeah, thank you for watching.